Good morning to all. So today we will discuss about the Woodward-Fisher rule for calculating the lambda max value in ultraviolet visual spectroscopy. Okay, so the rule by which we can calculate the lambda max for the given compound, that is conjugated diene and trienes, is a sort of rules. It is not just a single rule, but it is a set of different rules, and it is called as Woodward-Fisher rule for calculating the lambda max. So here are some terms for which we have to go through. So first of all, we have to learn all these value. For example, what is the base value for a cyclic or heteroannular diene? What is the base value of homoannular diene? What are the different increment value for the different substitution over there? Okay, so we have to discuss first what is acyclic or heteroannular diene or homoannular diene. So first of all, we are going to discuss. Let me share. Okay, so first of all, what is homoannular diene? So homo means same. Di means two, and in means double bond, means the double bond present in the single ring, that is homoannular diene. And one point is should be noted here, that the both the double bonds should be present in the same ring and separated by the conjugation. Okay, so in homoannular diene, the conjugated double bond are present in the same ring and having s-cis-wide configuration, single bond uh, joining the two doubly bonded carbon atoms. So here we can see the homoannular diene. Okay, so this is the ring, double bond, single bond, double bond. All these three structures are correspond to the homoannular diene because both the double bonds are located in a same ring. So here, this is homoannular diene, the heteroannular dienes. Hetero means different, annular dienes. Again, as we have discussed earlier, di means two and in means double bond. In heteroannular dienes, the conjugated double bonds are not present in the same ring, and these have S trans, that means transoid configurations. So here we can see the heteroannular diene. These two double bonds, okay, these two double bonds are present in the different rings. Okay, so if we talk about this double bond, this double bond, these two double bonds are present in different rings. If we call it a ring A, it is ring B. Okay, so this double bond is in ring A, the part of ring A, and this double bond is the part of ring B. Same here, this is in the different ring, this is also in a different ring. Okay, and so on. Okay, so next is exocyclic conjugated double bond. So exocyclic, exo means outside, cyclic. Cyclic meaning we are talking about ring. Conjugated double bond, that means the double bond which is present outside the ring. But what is the condition? That double bond should be in conjugations. Okay, so here are some example of exocyclic double bond. Okay, so if we talk about this structure, this is ring A and this is ring B. Okay, so for ring A, this one is the exocyclic double bond to ring A. And if we talk about this double bond, this is the exocyclic double bond for ring B. Basically, we have to see, we have to focus on this type of structure. Okay, if we have exocyclic double bond on this position, or at this position, or at this position, either at this position, and this position, all these bonds are exocyclic double bond. Okay, So if we talk about this particular structure, okay, so this bond is satisfying this condition, this particular condition. Okay, this is look like a, this is our ring A. Okay, and this is the exocyclic double bond to ring A, this particular ring, this particular bond. Okay, so same in the next. Here we have three rings A, B, and C. So if we talk about ring A, we have this double bond is exocyclic to ring A. And if we talk about B, we have the ring B have no exocyclic double bond. Okay. And if we talk about ring C, we have this ring exocyclic to C. Okay. Okay. And the next is alkyl substituents and ring residue. So particularly the alkyl substituent and ring residue is the same. Okay. These alkyl substituent and ring residue uh, differentiate in two condition, we can say. If we have cyclic diene, okay, and if we have ring containing diene. So if we have a cyclic dienes, we will call it alkyl substituents. And if we have a cyclic system, we call it ring residue. If we take this example from here, if we talk about this alkyl substituents, so basically alkyl substituents is nothing but the alkyl substituents and ring residue attached to the carbon atom constituting the conjugated system of the compounds are taken into account. So basically, we have to first of all we have to identify the conjugation. So if we talk about this particular area, if we focus on this particular area, we can see here there is a single bond, double bond, single bond, double, and single. So this is the part of conjugation. Okay, from where the conjugation has started. Single bond, double bond, single bond, double bond, and again single bond. It is a conjugation. So the substituents means whenever you see the substitution at where, only at the conjugation part of that particular diene system, that is called as alkyl substituent in case of aliphatic or in case of straight chain dienes. And here if we talk about this particular structure, we have double bond, we have single bond, and again double bond. So this is the conjugation, double, single, and double. And it is a base of conjugation. And how many substitution are there on that particular conjugation? This is the substitution and this is the substitution. Okay, so there are two ring residue at this. Okay, here are some example. So three ring residue. Okay, so if we, one second. Okay, so here are the some example or how to identify the ring residue. So here there are three ring residue. So how we have identified these? Because double bond, single bond, and again double bond. So this is the part of our conjugation. The first step to identify the ring residue or alkyl substituents is, first of all you have to identify the part of conjugation. Okay, so here we can see double bond, single bond, and double bond. So this is the part of our conjugation. And now we have to identify where is the conjugation. Where, sorry, not conjugation, where is the substitution. So here is substitution, means this is substitution. This is also a substitution to our conjugation, and this is also the substitution. Okay, so there are three ring residue in this case. So if we talk about this second structure, this particular structure, so here again, first of all, we have to identify the uh, conjugation part. So double bond, single bond, and again double bond. So this particular part, this particular part correspond to the conjugation. Okay, so we have double bond, single bond, again double bond. So now we have to identify the substitution, means how much substitution is there on that particular conjugation part. Either we have a cyclic system or we have a cyclic system. Again, I'm repeating, alkyl substituent and ring residue, these are the same thing. Ring residue we consider in the ring system, whereas alkyl substituents we consider in the aliphatic or straight chain diene system. The first step is we have to identify the part of conjugation. So here we have identified double, single, and double bond. Okay. So now here is how much is the how much is the substitution. So here is the substitution. Here is also substitution. This CS3 is also substitution on this particular conjugation. This is also again substitution. So here 1, 2, 3, 4. Okay, so here 1, 2, 3, and 4. This is 4 ring residue and 1 alkyl substituents. 1, 2, 3. So here 3 are ring residue and 1 alkyl substitution. So total are 5. Okay, so moving to the next example. The first step is we have to identify the uh, conjugation part. So here double, single, double, single, and again double. So this is the part of our conjugation. Now we have to identify the ring residue. So here, here, here. So total there are 3 ring residue and 1, 2. Total 3 ring residue and 2 alkyl substituents. So here total is 5 ring residue or 2 alkyl. We can add all these ring residue or alkyl substituents together because the increment for these are same. Here we can see the increment alkyl substituents or ring residue 5 nanometer, whether it is your alkyl substituent, whether it is your ring residue, both are the increment for both these are same. So 5 nanometer, we have to add the 5 nanometer in the base value. Okay, moving to the next. We have next next one is oh, okay. Here is different example. So if we talk about this particular example, CS2 double bond C, CS3, C, CS3, and first of all, we have to identify the base value. So this is not a homo Euler or diene system. Okay. So this is this type of these type of compounds is considered as alkyl sorry, as a cyclic diene. A cyclic diene means there is no ring. Okay, if there is no ring, that means it is a acyclic system. Okay, so the base value for okay, 1 second. Just a second. Okay, so this is this is the compound. So it is an acyclic diene. So acyclic diene, for the acyclic diene, we have the base value of 214 nanometer. Now, two alkyl substituents. So here is alkyl substituent. How to identify the substituents? First of all, we have to identify the conjugation part. So here double bond, single bond, double bond. Okay. So this is the part of our conjugation. And where is the substitution of alkyls? So this is our alkyl CH3 and CH3. We have two alkyl substituents. So we have increment 5 of each. So we have two alkyl substituents. So 2 multiplied by 5, that is 10. So the calculated lambda max for that particular cyclic diene is 2 to 4 nanometer, and the absorbed value for this particular diene is 2 to 6 nanometer. Okay. Okay, we discuss the more example. Okay. Okay, so this is our next example, example 4. Okay. So first of all, we have to identify whether it is our homoannular, whether it is our heteroannular. So homoannular, homoannular diene. Homo means same. So this is our homoannular diene because these two conjugated double bond are present in the same ring. These are the part of same ring. So it is homoannular diene. So in case of homoannular diene, the base value is 253 nanometer. Okay. And ring residue. Now, how will identify the ring residue? Again, we have to identify the part of conjugation. So this is the part of our conjugation in a homoannular diene system. Double, single, and double. Okay. So ring residue. Ring residue means that is a kind of substitution. That is 1, 2, and 3. So total we have 3 ring residue. So we have a 5 nanometer increment for each ring residue. So total ring residue we have 3. So 3 multiplied by 5, that is 15 nanometer. Okay. So one exocyclic double bond. Now, how will we identify the exocyclic double bond? As I have told earlier, that if we are trying to identify the exocyclic double bond, we have to just focus on such type of structure, either such type of structure, either such of structure, either this, or either this, or either this. Okay. So here, if I mark this as ring A and this is ring B. So ring A have no exocyclic double bond. Okay, as we can see here in the chemical structure of this particular homoallyl system. So here is ring B. Okay, so for ring B, this is the exocyclic double bond for ring B. Okay, because if we I draw it separate, so this will come down, look like this type of structure. Okay, so this is the exocyclic double bond to ring B. So only we have one exocyclic double bond to ring B. So for one exocyclic double bond, we have a 5 nanometer increment. Okay. So if we add this, the values, the total value of these uh, is about 273 nanometer. Okay. 273 nanometer. Okay. So the next example, that is example number 5. Okay. Okay, now the first step is we have to identify the whether the given diene is homoannular or heteroannular. So this is heteroannular diene. Why? Because the two double bonds which are in conjugation are present in the different ring. Here, if we call it ring A and this is ring B, okay. So this particular double bond is the part of ring B, whereas this particular bond is the part of ring A. So these two double bond are present in different rings. So that's why we call it a heteroannular diene. Heteroannular diene. So the base value for heteroannular diene is 214 nanometer. Okay. Now we have to identify the ring residue. Okay. Ring residue. First of all, we have to identify the part of conjugation. So this is the part of our conjugation: double, single, and double. Now, where is ring residue? So this is ring residue. This is also ring residue, and this is also ring residue. Ring residue means in a cyclic system. In a cyclic system, there is a cyclic system which is in conjugate. If we talk about double bonds, the two double bonds are in conjugation, and the substituents that are present on this particular conjugation, that is ring residue. So here is 1, 2 and 3. So we have total 3 ring residue. So 3 into 5, that is 15 nanometer. And again there is one exocyclic double bond. Okay. So if we talk, if I mark this as ring A and ring B. So again I have told that we have to identify such type of structure. Either we have such type of structure, either this, either this, either this, either this one or this one. Okay. So if we talk about ring A, okay. So ring A have no exocyclic double bond, whereas ring B have this particular double bond, this particular double bond correspond to the exocyclic double bond to the ring B. Okay, because this correspond to this structure. So for exocyclic double bond, there is an increment of 5 nanometers. So total we have 234 nanometer for this particular diene. Okay, we have more example. Okay. Okay, this is our diene system. So here the base value is 253 nanometer, and as we know, 253 nanometer is for homoannular diene. Here is one important concept which we have to discuss. If we talk about only this structure, okay, this is homoannular diene because this double bond is also in the same ring. This is also in the same ring. Okay, if I mark this ring A, ring B, and ring C. So ring B have two double bond in the same ring. Okay, so we can call it. We also can call it as a homodyne. But if we consider this, the double bond which is present here. Okay. Now we have two conditions. We have homoannular diene, the condition which is satisfying homoannular. We have homo, and also we have hetero. So we will consider this as a homoannular diene where there is a two system and we have to choose from homo and hetero. We always choose it as a homo, not hetero, because the value for homoannular diene is 253 nanometer, whereas for heteroannular diene there is a 214 nanometer. So we will take it as a homoannular diene. Okay. So for homoannular diene, the base value is 253 nanometer. Now one double bond extending conjugation. So what is this? Okay. Yes, first we will discuss the six ring residue. So six ring residue. How will we identify these ring residue in this particular dyne system? So again, the first step is to identify the conjugation part. So our conjugation started from here: double, single, and double. Okay. So this is the part of our conjugation. Now the substitution which is present on this conjugation, we take it as ring residue. Okay. So there are six ring residue. So this is one, two, three, four, 5, and 6. So total is 6 ring residue in this particular homoallodyne system. Okay. So 6 multiplied by 3, that is 30 nanometer. Now one double bond extending conjugation. Now what is this? Double bond extending conjugation. So particularly what is conjugation? Means if we talk about the base of conjugation, means a compound should have double, single, and double. This is the basic conjugation. Means there is a double, single, or double bond. It may be single, double, or single. Okay. It may be single bond, double bond, triple bond, then again double bond, triple bond, and again single bond. Means the position of double or triple bond should be at alternate position. Okay. So here double bond, single bond, and double bond. This is the basic of our conjugation. So how much double bond will extend further this particular conjugation? So here is only one double bond that extending this particular conjugation. Okay. So double, single, and double. Up to here we have basic conjugation. Double, single, and double. Now for this particular conjugation we have only one double bond that is extending this conjugation. So for such cases, we will take 30 nanometer as an increment per double bond extending conjugation. Okay. So here is only one double bond that is extending this particular conjugation. So here is 30 nanometer. Suppose if we have one double bond here, we will take it as 30 plus 30. Okay, we have to add 13 nanometer plus 13 nanometer in the base value as an increment, because now we have two double bond that is extending the conjugation. Okay. Okay. So now next is one double bond exocyclic to ring simultaneously. Okay, 10 nanometer. Okay, so here how will we identify the exocyclic double bond? Again, I'm marking this as ring A, ring B, and ring C. So here ring A, here ring A, this is our ring A, and this particular double bond is exocyclic to ring A, mean that is outside the ring A. Okay, such type of structure is there. This is our ring A, and this is exocyclic, this one. And if we talk about ring B, okay, if we talk about ring B, so for ring B, this one is the exocyclic double bond to ring B. Okay, so if I draw the ring B, so such type of structure is there in ring B, and this one. Okay, such structure is there in a ring B. So this is exocyclic double bond to ring B. Okay, so here is for ring A, this is exocyclic to ring A, and this bond is exocyclic to ring B. Now C for C, for ring C. Now for ring C we have two exocyclic double bond. Okay, if I draw ring C like this, here we will see we have such kind of exocyclic double bond and this one. So total is four. For this particular diene system, we have four exocyclic double bond. Okay, so there is here two exocyclic double bond and one double bond exocyclic to ring simultaneously. So 10 into 10. It is on up to you. Either you will add all these or either you will add separate. Okay, so total increment for exocyclic double bond in this particular system is 20 because 10 from here and 10 from here. So we have identify as uh, ring for ring A. There is a 5 nanometer. For ring B also 5 nanometer. So total is 10. And for C we have two exocyclic double bond. So 5 plus 5 that is 10. So total is 20 nanometer. Okay. So the calculated lambda max for that particular compound is 333 nanometer. Okay. So that's all for now. In the next lecture, we will discuss the Woodward-Fieser rule for the alpha beta unsaturated aldehyde or ketones. Okay, thank